Yeah. So what did we do? What did we study about CNNs in the last 2 sessions? What are CNNs first of all? Convolutional neural networks. Why do we use CNNs? When we have data set with what? Images. Okay. So ANN has few drawbacks when it processes images. Hence we go for working on with CNN when we deal with image data set. Okay. So we have seen some basic concepts of CNN. What did we see? There are 2 important blocks when you process an image. Okay. One is feature extraction, one is classification. How is feature extraction done in an image for CNN? 3 layers. What are they? Convolutional layer. Convolutional layer, after that? Pooling layer, activation function. Yes or no? Did we see this or not? Why do we use, what is convolutional layer? To extract the features. How do we extract the features using convolution layer? By applying filters called kernels. Okay. So convolution layer is basically used for extracting the features from the image by applying filters called as kernels. Okay. After convolution layer we apply activation function. Why do we apply activation function? To introduce nonlinearity and remove all the other elements which are not required, and only the elements which has important features. Okay. After activation function, what do we do? We apply, come and sit here in the front. After applying it to the activation function, what do? We apply it into pooling layer. Why do we use pooling layer in CNNs? Why do we use pooling layer in CNN? To reduce the size of the image. To reduce the size of the image. Okay. So after we are done with these 3 steps, what are the 3 steps? Convolution, apply activation function, pooling layer, we convert that to fully connected layer. We connect that to fully connected layer and then calculate the loss function. This is all forward propagation. Okay. So what are we doing in forward propagation? We read an image. Look at this. We read an image. Okay. When we read an image, the image would be read in a tabular form with pixel values like what you can see in the first figure. And I apply a filter, the second figure, the loopy pattern filter on the original image, and then we try to generate what? A feature map after I apply convolution, that is the third figure. On the feature map we apply activation function. I have applied ReLU here. We get the reduced feature map, and on to the feature map I apply pooling, and then this will be connected to fully connected layer, and from there we go for calculating our loss function. What is loss function again? Actual values minus predicted value. So for regression we will be using mean square error or mean absolute error. For classification we will be using, if it is binary class we will be using binary cross entropy. If it is multi-class we will be using categorical cross entropy. Okay, it is same like what we have done for ANNs. This is all about what? Forward propagation. So today we will be doing until forward propagation. Okay. So what were the 4 exercises that we have already discussed? Exercise 1 was on convolution, apply convolution on a matrix. What was exercise 2? Apply pooling on a matrix. This was done in the first session. And in last session what did we do? Take an image, do some pre-processing on the image, apply some convolution on that, and then pooling on that particular image. So what are we going to do today? Combine 3 steps. What are those 3 steps? Convolution layer, activation function, pooling layer, train the model. How do you train the model? By putting these 3 things together. First we apply filters, and then activation function, and then pooling layer, and check your predicted output. Okay. Now the data set that we will work on is MNIST data set. What is MNIST data set? Handwritten digit recognition data set, which have 10 classes. What are the 10 classes? The numerical 0 to 9. So when I give an input as 9, my output should be given as what? Is it 9 ante? Out of 10 values, only 1 value should have the highest probability. Okay. So, yeah. So, as you can see, convolution layer plus activation function and then pooling. Okay. Now, listen, what is the difference between this image and this image? I have only one convolution and one pooling here, whereas in this image what did I do? I have taken two convolution layers and two pooling layers. We are also going to do the same today. Okay. We will not take only one convolution and one pooling. We will be doing what? Multi-layer CNN. When I talk about multi-layer ANN, what do you mean by that? Multiple hidden layers. When I talk about multi-layer CNN, what do you mean by that? Multiple convolution layers and multiple pooling layers. Atlani, don't take one convolution, then pooling. Not like that. It is a set. Convolution, activation function, pooling is one set. After this, another convolution, activation, pooling. After this, another convolution, activation and pooling. Okay. So, we will not limit to 3 or 4. We will do only 2 layered CNN architecture today in the class. Are you all okay with this? Okay. Now, what is the change here? Reading images, we have already done. Pre-processing the images, we have already done. How to perform convolution operation, we have already done. How to perform pooling operation, we have already done. Activation function is the new thing you have to define and then put all these 3 together for training. These are the only 2 new things that we are going to do today in the session. Okay. Now let us see what are we going to do. Okay. Now what can you see here? What is the exercise for today? Build a CNN model with following requirements. What is step 1 that we are going to do, guys? Input layer accepting 28 by 28 by 1 image. Okay. What do you mean by this? If suppose I give you a color image, what would be the size of that? It may be of any size into 3. The dimensions would be what? Into 3 if it is color, because RGB. If suppose I take an image of 256 by 256 size colored image, the size of the image is given as 256 by 256 into 3. Okay. But what am I telling you here? Into 1 means what? Grayscale image. So, even if it is a colored image or even if the image is of any size, what are you supposed to do? You have to do some pre-processing wherein you will convert the image of any size to what? The standard size, that is 28 by 28 and into grayscale. Is that clear? You take any image, but what is my requirement in step 1? Convert the image into size what? 28 by 28 into 1. Into 1 means what? You have to convert that into grayscale. Is that clear? Meeru color image తీసుకొని direct గా అట్లానే process చేస్తే your test case will not be matched. Because in our test case, in our model, the image is what? Of any size. You can take any image of any size, but you should convert that into fixed size of what? 28 by 28 and you should convert that into grayscale. These are the 2 pre-processing that we are going to do today. Okay. After that, what am I going to do? Apply 2 convolutional layers and I have given you the filter size. Okay. What is the size of the first filter? First with 32 filters, second with what? 64 filters. After that, apply activation function onto the convolution layer and then max pooling layer after each convolution. We are taking 2 convolution layers, right? 1 convolution, activation function, pooling. 1 convolution, activation function, pooling. That is, we are building our CNN models with 2 convolution layers, 1 activation function for each of them, and then finally we take a pooling layer. Okay. And then you have to give dense layers for classification. This is nothing but connecting a fully connected layer. The output of the pooling would be given to FCN, fully connected layer, and then go for probability prediction. Okay. Now, when we talk about activation functions for probability, which activation function do we use? Softmax. Very good. So, which activation function do we use? Softmax, because I have numbers from 0 to 9. So, I may get any value in between 0 to 1. The one with highest probability will be considered as the output. For example, I have 10 values in my output. If suppose I take digit 1, I have numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If suppose I take 1 as input image, okay, in these 0 to 1 values, whatever I have, one should have more value compared to others, which says that the output is for digit 1. Okay. So, this is what we are going to do today in the session. What are we going to do? take an image, read that particular image, convert that image into 28 by 28 by 1, that is grayscale image, apply 2 convolution layers, activation function, 2 pooling layers, and then go for calculating FCN and then predict the output. We are only doing forward propagation, but this is not the complete architecture of CNN. We may get loss function whose value may be high. So for this process, what do? We go for backward propagation, that is training the model with backward propagation, changing the gradients, applying different optimization algorithms, and then repeating the process. Okay, that we will do later. For today, we will complete one process flow of forward propagation in CNN, building the CNN model for forward propagation. Is that clear, everybody? Okay. Yeah. So first you have to import the libraries NumPy and PIL. PIL is Python image library. Okay. So which we generally use for reading the images, pre-processing the images, applying some filter onto the images, making some image modifications. We'll be using this Python image library. Okay. And then we have to load and pre-process the image, initialize the weights. What do you mean by initialize the weights? Filter size and the input image size. Okay. Define activation functions ReLU and softmax. Where am I using ReLU and where am I using softmax? In the first layer we use what? ReLU. In the second layer, that is when I connect it to the output, I want probability of prediction, hence I am using softmax. Okay. So one convolution layer, ReLU, pooling layer. Another convolution layer, softmax, pooling layer. This is how we work. Okay. And then convolution operation, pooling operation, forward propagation, perform CNN with the image. Is that clear, everybody? Yes or no? We will on the exercise. Please open that. You can find the exercise with the name CNN Multilayer 1. CNN Multilayer 1. In the first step, please import the libraries. So what are the 2 libraries that we want? For performing convolution operation where I do some multiplication, element-wise multiplication, I need NumPy. And for loading the images, I need PIL. Okay. So import NumPy and Python image library. Import the libraries NumPy and PIL. NumPy for element-wise matrix multiplication while we do convolution operation, and also for pooling when we go for mean or average, we also need NumPy. Okay. So first import NumPy and PIL libraries. PIL in caps. Try working on loading and pre-processing the image. Okay, we'll give you the image path, complete that block. Okay, yeah. So what are we going to do here? 3 steps. Okay, one is we have to resize the image as I told you to the size what? 28 by 28 into 1. Okay, and then you also have to convert that to what? Grayscale image. And also we are doing what? We have to write a function that actually takes that image file path. We have to convert that into grayscale. We also have to resize that particular image. Normalize pixel values. What do you mean by normalize pixel values? Usually the pixel values are ranging from what? 0 to 255, but we are converting them to range in between 0 to 1. Okay. So perform normalization. Add a channel dimension. That is, I want 28 by 28 into 1 channel image. Okay. So we will do this job of adding a channel dimension, saying that my image is of 28 by 28 into 1. So first read the image, convert that into grayscale, okay, resize the image, apply normalization, and then add a channel. These are the 5 things that you're going to do in this block of code. Okay, try doing that. We are not working on the entire MNIST data set now. Okay, we are working on one image from the data set. Okay, because you have to know how convolution, how filtering, how pooling, how fully connected layers work on one image. In the next session, we'll work on the entire data set with backward propagation. We'll slowly take it step by step. Okay. We are not working on the entire data set, only one image. Okay. So first take a function which reads the image, that is image loading. Convert that image into grayscale. After that, resize the image. All the functions are available for this in NumPy. Okay. We want you to read the image, convert the image into grayscale, normalize the value, pixel values from 0 to 255 to 0 to 1. add the channel dimension such that the image would be taken as 28 by 28 into 1. After you perform all the operations, return the processed image as a NumPy array. Because for convolution, we don't take the image directly. We take an array for processing the convolution operation. Make it fast. We have to go for convolution, activation and pooling also today. There's nothing difficulty in this. Convert to grayscale. Okay. Resize the image using resize function and then normalizing the pixel values. How do we use normalize? How do we normalize? NP dot? Array image by 2. Yes. Divide that by 255. As simple as that. We've already done. Okay. So once you're done with grayscale, resizing, normalizing, you have to add a channel image. Channel dimension 28 by 28 by 1. I'll just give you the code for a glance. You just have to just refer this and then you can do. Look at this. First, I'm defining a function. This is a function that I am taking. I am just passing the parameter image path. I don't give the image, don't give the entire path. Just pass the parameter variable. Okay. So image, as you can see here, see, listen when I explain. Don't just type. The code will not be visible for long. Listen and then you can do it. Okay. In that way, you'll learn and you'll complete your exercise. Okay. So this is the image path. I am taking a variable name called image path and I'll pass this as parameter inside the function. Okay, don't give the image path. Just give the variable image path as the parameter inside the function. Because I'm going to read this image while I train my model. I'm not going to do any operations here. Okay, so first what I do is I open that image and then I convert that into grayscale. Okay, so this is how I convert into grayscale. And then for resizing, I just use the function resize. No matter what the size of the image is, I want to resize it to 28 by 28. And then if I want to normalize the pixel values from 0 to 255 to 0 to 1, I'll simply take an array of the image and divide that by 255. And for adding channel dimensions, I say np.expand underscore dims dimension, give the size of the image array, comma axis is equal to 0. Why do I take axis is equal to 0, axis is equal to 1? For row we take what? 0. For column we take? Okay. So here I am bothered about 28 by 28 into 1. Hence I take axis is equal to 0. This is how I perform channel dimensions, adding the channel dimensions. Okay. So let me repeat. Define the function, give the image path as parameter. First perform opening the image and converting to grayscale. Resize the image size, convert the image into NumPy array and normalize to 0, 1 and then apply channel dimensions onto the same. Okay, now try it. Image path now, just pass that parameter. That's what I'm telling you. Don't require image path now. Okay, don't get confused. Just to give it in the function as it is. If I give you the image path now, you'll type the entire thing here. Finished? How many of you have completed this? Loading and pre-processing the image? Why? Good. Okay. What is the next step? What is the next step, guys? We have to initialize the weights. Okay. You have to initialize the kernel weights. Please do that. Convolution layers are actually used for extracting the features. These filters need to be initialized before we actually train the network. We know the size of the image now, 28 by 28. But we have also, see, somebody asked me, how do we define the filter size? By using random. Okay, randomly we have to just give the filter size and the values inside the filter would be randomly generated. Okay, so please do that. Initialize weights for the filters. So we have two convolution layers. So we have to take two filters. I told you the size of the filters. 32 filters in first convolution layer, 64 filters in second convolution layer. Please write the code as per that. Define the convolutional layers with filters where you are supposed to take 32 in the first convolutional layer, 64 in the second convolutional layer. Write the code to initialize 32 filters, each of size 3 by 3. The filter size is 3 by 3 with 32 filters. The second convolutional layer should also have filter size 3 by 3 with 64 filters into it. Let me just give you a glance. See, convolution, I am taking the variable called conv filters layer 1 np dot random rand n 32 filters 3 by 3, 64 filters 3 by 3. Why am I multiplying it with 0.01? Why am I multiplying it with 0.01? Because randomly generated weights may be any big values. I want to take very small weights because while in training backpropagation, I want to change these weights multiple times and improve my accuracy by the reducing loss function. Hence, the weight should be, even if they are randomly generated, the weight should be very small. So, I randomly generate them first and then multiply that with 0.01. Hence, the size of the weights would be small. Okay. How many of you have done this with? How many of you have completed this? See, convolution filters layer 1, random dot random 32 by 3 into 0.01. Second layer 64 comma 3 comma 3 into 0.01. That's it. You know how do you do that? So what are the activation functions that we need for this particular exercise? ReLU and softmax. Why ReLU? For the first convolution layer. Why softmax? For the output layer which takes the probability, that is softmax. Okay. So define the activation functions ReLU and softmax in the next block. And please, you have test cases for each one of them. Okay. This is a graded exercise. Write the code for activation functions ReLU and softmax. Write the code for the activation functions ReLU and softmax. We take only positive values into consideration. Hence, it is max of 0, x and define softmax. Okay. After doing that, I'll also go for image height and image width. Okay. So, as I'm handling 3D image here, that is the dimension of the image is 28 by 28 by 1. It is a 3D image. Okay. Though it is grayscale, it is a 3D image. Hence, I go for image 1 colon. Okay. Now, once I am done with that, I'll apply striding onto the image height and width. Okay. So, listen to this. I am taking an input image, I am taking a filter and I want to generate the output filter. Okay. So, how do I generate this output feature map? By applying this filter onto the image, by applying striding, I want to generate the new feature map. Okay. So, I say output height and output width are nothing but image height minus kernel height divided by stride plus 1. That is, I am striding. Okay. So, this is how we calculate output height and width. And why am I taking output is equal to np dot zeros? My initial output is 0. I don't want anything. Once after I perform filter on the image, I want to upload or append those values here. So, initializing the output image basically with what? Zeros before I apply filter. Okay. Once you do this, you have to iterate over the filters. What is INJ here? The row and column size. First, generate the filter dimensions. Declare the output feature map size and load all zeros into that by using np.zeros. Okay. Take a loop where you iterate over filters. Take the current filter with INJ row and column values. Append the filter values once every operation is done. Once apply filter onto the first part of the image, append those values onto the feature map. Stride the filter, calculate the values and append that onto the output feature map. Similarly, repeat it till the entire image is covered with the filters. Okay. How many of you have completed convolution operation? Let me reevaluate. So we have two test cases here. One for activation function, one for convolution. Okay, 64. Okay. Only 8 submissions for the entire module. Yes, we'll give you 5 more minutes to complete convolution operation. We'll on another exercise wherein you'll complete pooling and then training the model. Okay. Complete this. We'll off this in 5 minutes. You can see the next exercise, CNN Multilayer 2. Please open that next notebook. CNN underscore multilayer underscore 2. We will stop exercise 1 in 2 minutes. Yeah. Are you able to see exercise 2? Multilayer 2, anybody? Are you able to see exercise 2? Multilayer 2? Okay. Yeah. So far, we have imported libraries, we have done pre-processing, we have initialized weights, we have defined activation functions, we have defined convolution functions. Okay. Now in the second module, what we have to do is we have to complete pooling. Okay. So in the next notebook, you have to define pooling. All of you know how to do pooling. Please carry on with that. If you are done with convolution operation, please proceed on pooling operation. So you have two test cases, one for pooling and the second one for forward propagation. Okay. So forward propagation is nothing but all these functions used at a time in order. First convolution, activation, pooling. Second convolution, activation, pooling. Okay. Yes, all of you please start working on pooling operation. The second in the second notebook. CNN multilayer underscore 2. Yeah. So we have closed exercise 1. You please switch on to exercise 2. Okay. We have evaluated 1 again. Okay. So we have opened 2 where you can see the code 1 thing. Start working on exercise 2. Complete pooling first. Pooling is very simple operation. Please complete that first. Complete pooling. Implement function called max pooling. Okay. So we have two types of poolings. What are they? Average pooling and max pooling. What is max pooling? What is average pooling? Yes, maximum of the matrix is max pooling. Average of the values in the matrix is average pooling. Okay. So what is the pooling window that we are asking you to take? Size of pooling window? 2. 2 in the sense 2 by 2. All of you start working on pooling. We have already done this in the last session. Do we have to apply stride again on pooling? Yes. Why? Because we are applying pooling on what? Pooling on the matrix. Okay. So the matrix size may be of n by n. The pooling size is what? 2 by 2. So I'll stride pooling size also on the entire image. Okay. The entire feature map. So similar to convolution operation where we apply filter on the image, we apply pooling filter onto the feature map that we get from the convolution operation. Okay. Please do that. Complete the pooling operation. Apply pooling operation. Apply striding on the pooling operation as well, because you have to complete the entire feature map by pooling, covering every part of the image. Okay. Once you are done with pooling, we'll see forward propagation. How many of you have completed pooling? Okay. Okay. So for those who are not clear about pooling, let me explain you once again. Okay. So you have to define a function called max underscore pooling. Okay. So the parameters that I'm passing here is the image. Stride is equal to 2. Size is equal to 2. What do you mean by size is equal to 2? The pool size, the pool matrix size that I am taking is 2 by 2. So when I am taking pool size of 2 by 2, striding also should be 2 by 2. Why? Once I am done with this one block, I have to shift 2 times. Hence I am taking stride is equal to 2. So these are the parameters that we pass, and we have to perform max pooling on each feature map independently. How many feature maps do we have here? We have 2 convolution layers, hence we have 2 feature maps. So we have to apply pooling individually on separate convolution layers because one is of different size, the other convolution layer is also of different size. One has 32 filters, one has 64 filters. Okay. So for F in range is what? F is nothing but the first feature of the first convolution layer. F2 is nothing but the second feature of the convolution layer. Okay. What are I and J? I and J are nothing but the row height, the row value and column value of the pooling. Okay. So I am taking 3 for loops here, for F, for I, for J. F is nothing but the number of filters that have to apply depending on the convolution layers. I and J are nothing but the row and column values that I take by performing the pooling operation onto the feature map. Okay. So perform pooling on each feature map independently. So we are doing 2 convolution layers. We have 2 outputs, 2 feature maps. So perform pooling on first convolution layer. After that you perform on second convolution layer. Okay. You have to complete pooling and then leave the class today. This is just for your understanding. We have put the code. So the difference between last time code and this code is, last time we have taken only one convolution, one pooling. Okay. But here for multiple convolutions, you have to go for multiple poolings. Okay. So there would be slight change in the loop structure. Please try to understand the loop structure because we are taking 2 convolution layers here. In the last example, we have taken only one convolution. We have for F, for I, for J. Okay.